Today we are going to talk about quadratic functions and their transformations. And so quadratic functions you saw in Algebra 1, and so we are going to revisit those, talk about their key features of the graph of those functions, and then we're going to look at transformations applied to them. And then you guys will have an assignment on Delta Math to complete that will practice the things that we are going to talk about today. Right? So your objective today is, your first objective is to identify key features of quadratic functions. And then your second objective is to identify transformations on quadratics or quadratic functions. Okay. So we're going to look at key features of quadratic functions first. The graph of a quadratic is called a parabola. So here's your kind of a vocabulary word, parabola. And that's the graph of the quadratic function. Okay, and it is U-shaped. It will either open up or down. So it looks like this, or looks like this. All right, so the parent function for quadratics is y equals x squared, or f of x equals x squared. All right, and again, you studied those in Algebra 1, learned all kinds of things about them that we are going to revisit in the first part of this chapter in your textbook. All right, so if we graph y equals x squared, just kind of like a quick table of values. So y equals x squared. So we go -2, -1, 0, 1, 2. If those are my input values I'm going to look at, my y values. So I'm squaring them. So if y equals x squared, then that's going to be -2 squared, which is -2 times -2, so +4. -1 squared is going to be +1. 0 squared is 0. Okay. So I'm just plugging those x values in to the equation, and that's just going to kind of give me some points to plot on my graph, which hopefully you guys kind of already know where these are going to fall. Right. 1, 2, 3, 4. 1, 2, 3, 4. Alright. And that's negative. Alright, so let's just kind of plot these. So at -2, I'm up at +4. At -1, I'm at 1. 0, 0, 1, 1, 2, 4. All right, and I'm just going to connect those dots, and since I know it's a U shape, I'm going to curve it there at 0, 0. Well, if I can graph, obviously I can't do that very well today. That's a little bit better. Okay. That should be a very smooth line right there. Okay. All right, so that's the graph of y equals x squared. So there's your parent function for your quadratics. There are some really cool things about this function. The first thing, if you think back to when we talked about our even and odd functions, and we looked at the symmetry, this one has nice symmetry about the y-axis, right? And so the parent function x squared is symmetric about the y-axis, so we know it's an even function, right? And so, but it doesn't matter where the parabola is on the graph, it will always have a line of symmetry, okay? That line of symmetry is important for a couple of reasons. One, it divides the graph in half. It goes through this low point right here, which has a special name that we're going to talk about in a second. And so it's kind of an important line. That line of symmetry is called the axis of symmetry. So that is your vocabulary word for that, axis of symmetry. The axis of symmetry always goes through this point here. In this case, it's a minimum. If I were looking at one that was upside down, it would be a maximum. That part of your graph is called your vertex. Okay, it's going to be either a minimum or a maximum, depending on which way your graph opens. Okay. So the vertex is at 0, 0, so that's a coordinate point. Okay. The axis of symmetry is actually an x equals equation, so that's x equals 0. All right. There are a couple other vocabulary words that show up as we move forward in our Algebra 2 topics, and one of them is zeros. Zeros are your x-intercepts. Okay, so that is a synonym for x-intercepts. Okay, and so it's where the y value is equal to 0. And so that's where it crosses the x-axis. So where it crosses x-axis. Right. And then your y-intercept, of course, is where it crosses the y-axis. Let me clean that up. Okay. So we've talked about the vertex, the axis of symmetry, your zeros and your y-intercept. Okay. All right. Okay. The other two kind of vocabulary big idea things that show up as we move forward are domain and range. And hopefully from Algebra 1, you remember that the domain are the x values that you can input into the function. And so in this case, the domain for a quadratic is always all real numbers. Always all real numbers. We can denote that with a fancy R. So you make two vertical lines and then kind of make your R over it. Or in interval notation, that's negative infinity to infinity. Okay. And then your range is your set of y values. Okay, and so if I'm talking about the range of y equals x squared, that's going to be y values greater than or equal to 0, or I'm going to do my interval notation. Since it can be equal to 0, I'm going to use a square bracket, 0, comma, infinity. Okay, so that's y's that are greater than 0. And that's because if I square a number, and all I'm doing is squaring that number, it's never going to be negative, right? And so that's where those y value range comes from. Okay. Once we start looking at transformations and we look at graphs that have been shifted, they've been, moved up or down in the graph, they've been reflected over, so they're negative instead of positive, then that range is going to change. And so we're going to look at some of those. Okay. Okay, so you should have a half sheet of paper that has 4 problems on it that says identify the characteristics of the quadratic. You're going to glue those into your notebook. And we're going to kind of go through those together. So we're going to kind of use them as some examples for you. So if you if you will just kind of pause the video, make sure that's glued into your notebook, and then we will work those together. Okay, so you've glued your examples into your notebook, and now we're going to work through a couple of them. So we're going to talk through 1 and 2, and then you're going to pause the video and attempt 3 and 4, and then you can check your answers by playing the video again. Right? All right, so let's look at this. So it's listed all of these characteristics of the quadratic function, and we just want to know kind of what those pieces are. All right. So if I look at this, it asks me about the vertex. This is the first one. So the vertex, remember, is that minimum or maximum. So in this case, it's going to be right here. So I'm going to do that one in red. And so the vertex is always an XY point. And so in this case, the x value is 3, the y value is -1. And so that vertex is 3, -1. Okay. All right. It asks about the axis of symmetry. So remember that the axis of symmetry is the line that divides this graph in half, and it's always going to go through that vertex. Okay. So here in purple, I've kind of dotted that in. And so it will always be an x equals. And in this case, it's x equals 3. Okay. Notice that the x value of the vertex and the equation of the axis of symmetry match. Right. And so that will always be the case. Okay. All right, up or down, opens up or down. Which way is this graph opening? And so my ends are going up, so it opens up like a cup. That also tells me something, another characteristic of the graph that we'll talk about when we talk about transformations. Okay. Is your vertex a minimum or maximum, or does the graph have a minimum or maximum? And so remember that a minimum is a low value and a maximum is a high value. And so if I look at this vertex right here, that is a low point on the graph, and it's actually the lowest point, so that's a minimum. Okay. All right, remember then, so let's look at this next one. It asks for the zeros. Remember that the zeros are the x-intercepts. Okay, so where does it cross the x-axis? And so that happens, well, it helps to turn my pen on. So that crosses here at 2 and here at 4. I'm going to list those zeros as XY points. So that's 2, 0, and 4, 0. All right, and the next piece that it asks for is the y-intercept. And so that y-intercept is where it crosses the y-axis, and so it crosses the y-axis at 7. I'm also going to list that as a xy point. So remember, your x value is 0, your y value is 7, and so that's the point 0, 7. Domain. So as a reminder, I told you already, the domain will always be all real numbers. So there's my fancy R for that. Again, remember, you could write out all real numbers, or you could use that interval notation of negative infinity to infinity there. Right. And then your range, remember, is your y values. And so something that I sometimes do to help is I highlight. So I find my low point on my graph, which is this minimum at the vertex. And that corresponds to y equals -1. And then I look for my high point. Well, my graph keeps going, as indicated by the arrows. And so it goes all the way up. And if I look at that as going up forever, that's going to go up to infinity. And so my my range rather, is going to start at -1. And it's going to go up forever to infinity. And so I'm going to start it at -1, and it's going up forever to infinity. Okay. And then you always want to list those lowest values to highest values. So you're going from the bottom to the top when you list those for your range. Okay. All right, let's look at the second one. So these are in the same order. So you're going to identify your vertex, your axis of symmetry, your opening direction, whether or not you have a minimum or maximum, your zeros, your y-intercept, and your domain and range. Now, you don't have to do those in that order. That just happens to be the order that they're listed. So I'm just going to go down through them in order. But if you are more comfortable with answering some of those first, then you can absolutely do that. Okay. All right, so vertex. In this case, that's up here at the top of the graph. And so that point is 2. It sits between 12 and 14, so we're going to call it 13. So that's at 2, 13. All right. Remember, the axis of symmetry is that line of symmetry that divides the graph into two pieces, or into half rather. And it will always pass through your vertex, and it will always be an x equals. So make sure you write that as an x equals. In this case, that's x equals 2. This graph is pointing downward, so it opens down. And that also tells me that I have a maximum. So this vertex here is at the top of the graph, so it's a maximum. So if it opens up, as in number 1, it will have a minimum. If it opens down, like it does in this one, it will have a maximum. Okay, and that will always be the case with quadratics. All right, zeros. Where does it cross the x-axis? And so in this case, it crosses at these in-between marks. We're just going to call those halfway. So we're at -1/2, 0, and 4.5, 0. Okay. Y-intercept, it crosses here between 4 and 6, so we'll just call that 5. So it's at 0, 5. Okay. Your domain is all real numbers. I'm going to write that using that interval notation just so you can see that. It doesn't matter to me which notation you use. And then the range is your y values. Okay, I'm going to use the highlighter again, and I'm going to highlight. And so here at the bottom, so if I start at the bottom and look, I'm going down. So I'm going down to negative infinity, right? And if I look at where it stops at the top, it stops here at 13. So if I just kind of highlight this graph, I'm going from negative infinity to positive 13. And so when I write that out, I'm going to write negative infinity and 13. You will always use parentheses on your infinity and negative infinity because you can never actually touch those values, so you can never actually be equal to infinity or negative infinity. And so when we do that interval notation, just as a reminder that that is a parenthesis. And then on the 13, since the graph does touch 13, the y value does equal 13, we're going to use a square bracket. Okay. All right. So there's those key characteristics. All right, what I want you to do now is I want you to pause the video. I want you to do questions number 3 and 4. And then you will restart the video to check your answers on those in just a few minutes. And then we are going to talk briefly about transformations. All right, hopefully you paused the video and are now checking your work. I'm just going to quickly go through and write the answers in here. Maybe. There it goes. All right, let's see. 3, negative 25. All right, so that's 3, negative 25. That means your axis of symmetry is x equals negative 3. That one opens up, so it has a minimum. The zeros are at 5, 6, 7, and 1. So negative 7, 0, and 1, 0. It crosses the y-intercept here. Be very careful of your scales. 1, 2, 3, 4, 5. So that's multiplying by 5. So that's at negative 10. Okay. Domain is all real numbers. It has a minimum of negative 25, and it goes up forever. So negative 25 to infinity is your minimum. Right. Number 4 did not have scales, so I'm just going to count those by ones just to keep things simple. So the vertex is at 1, 3. Axis of symmetry is x equals 1. It opens down, so that means it has a maximum. The zeros are at negative 1 and 3, so negative 1, 0, and 3, 0. It crosses the y-axis at 2, so 0, 2. And then the domain, of course, is all real numbers. Since it opens